I'm going to come down here and just navigate to my counter. I want a simple count up, and I'm just going to drop that right in here. So here we go. We've got a call CTU, and now we can define what we're going to be working with. We're going to be working with ints. So let's go ahead and take that and set it up, give it a name. And now we need to figure out where all of our data is coming from. So what are we going to be counting? Well, let's count up a switch. So I'll go ahead and define switch. And we need a reset for this counter, so I'll just call that reset. We need a PV, a preset value, so I'll go ahead and make that 5. We need something to energize when this thing finishes, so I'll say counted down. And then we need a place to store what our actual count is while we're counting. So we'll just call that count. And let's go through and define these things. So switch, that's going to be global memory Boolean. The same as reset, which is going to also be global memory Boolean. Our count is going to be global memory integer. Our counted down is going to be Boolean global memory. Okay. So we've got all of that stuff set, and just like that, we've got a counter in STL. So we can put this within a label. You know, obviously, like I can come right here and I can define a label and then jump to this conditionally. So I don't have to run this counter all the time, but just for simplicity's sake, let's go ahead and do it that way for now. So I'm going to dump this into our PLC, load it, and let's go to our watch table. We need to control switch, and I don't really care about this reset. So let's just worry about switch, count, and counted down. So where's our watch table? Here we go. Let's get rid of all this junk. And we want our switch, count, and counted down. And we're already running with these. So our switch is false, our count is 0, and we are not counted down yet. All right, that's exactly what we would expect. So let's start toggling our switch. And look at that. We got our first count. So let's toggle that switch one more time. Back to false, back to true. There's our 2. And sure enough, you can see that this thing is working. It's counting for us. I can go all the way up to 5 if I want. And you know, I usually spare you the boredom of doing that. But in this case, I'm feeling just a little bit masochistic. And I want the satisfaction of seeing something all the way through. So here we go. Set that guy to 1. And look at that. Counted down is true. Our count equals 5. And just for fun, if I wanted to reset this thing, let's see, make that false, make that true, and yeah, reset our counter. So coming back in here into our program, you know, we can pull in a count up. If we want to pull in a timer, guess what? There it is. And you already know how to fill that in. You know what your input is, what actually energizes it. You know what your PT is, your preset time. You know what your Q is. That's what energizes when this thing's done. And you know what your elapsed time is. That's going to hold the time value of how much time has already passed. And, you know, when you get into any of these, you know, I showed you how to move something in STL by using the T command. But, you know, if you wanted to pull in a move block, guess what? you can move, and here you just move val1 over to val2, and it's just that simple. So most of these blocks, I showed you how to do an FP, front positive, but if you just wanted to use right trigger, you can pull that in here, and there you go. You've got this command, this function right here. But again, is it really STL programming to do it this way? It doesn't feel like it. So for some of this stuff, there are two ways to get it done. You can do it using STL, or you can do it just dragging these functions in here and taking the calls.